All right, I'm going to go over Charles's law. So, Charles' law states that the volume of a given gas, wow, that's ugly, at constant pressure, so there's your new variable that stays constant, is directly proportional to its temperature. So, just a little warning here. This temperature must be in kelvins. If you do not remember how to convert, it's just degrees Celsius plus 273.15 or 273, whatever. It's very close. And then that will be whatever in kelvins, so X kelvins. All right. So because it's directly proportional, we're going to write V and we're going to write T because our pressure is constant. If the volume goes up, the temperature goes up. If the temperature goes down, volume goes down. Think about a hot air balloon. When they heat the gas up, balloon inflates. It's the same. That's kind of concept we're going with. All right. So I'm going to give you an example, and we're going to work on this, and then that'll be it for this one. So none of these are too difficult to calculate. It's just basic math. So calculate the decrease in temperature in Celsius when 2 liters of gas at 21 degrees Celsius is compressed to 1 liter. So this is going to require some initial conversions. So first, let's get that into kelvins. So 21.0 degrees Celsius plus 273 equals about 294 kelvins. So now let's solve the rest of it. We have a temperature and we have 2 volumes. So the way you put this one into an equation is you have V1 over T1 is equal to V2 over T2. So it's a ratio. It should be the same as the ratio should be the same. So even though the numbers will change, if you divide them out, they'll give you the same number. So let's start with solving this. We have 2.00 liters divided by, and then we have 294 kelvins equals 1.00 liters over T2. We don't know what that is. So, pet peeve of mine is cross multiplying. I know it's probably like the easier way for you to do all these, but sometimes it creates mistakes, bad habits, more work. So I'm not going to solve it like that at first. I'll show you at the end how you would do it, but I'm going to show you the way I would do it. So really, all you have to do is somehow isolate T2. So multiply T2, and then you're going to have T2 times 2.00 liters over 294 kelvins equals 1.00 liters. So then, since we're using a calculator, it's not really hard. You just divide this ratio out. And then you divide it over here, and it'll cancel. So when you're dividing by a fraction, you're essentially multiplying by its reciprocal. So that means T2 equals 1.00 liters times 294 kelvins over 2.00 liters. So your liters are going to cancel, and essentially you're going to have 294 divided by 2. So 294 divided by 2 is 147 kelvins. And then we have to do one more thing and convert it back to Celsius. So 147 minus 273. That's going to be negative 126 degrees Celsius. That would be your answer. Now, I'm going to go over how to do it with cross multiplication just because I know you guys all like that, but I am not a fan. Alright, so let me fix this so it's all nice and neat. So all you do is this. You're going to end up with the same thing that I just wrote. So you're going to have 2.00 liters times T2 equals 294. So 294 Kelvin, 1.00 liters. Divide by 2.00 liters, 2.00 liters. Same exact thing. But this isn't really like a math equation or way of solving stuff. It's just a shortcut for doing the same thing I just did. So it's going to give you the same answer. You can use either method you want on a test, just don't make a mistake.